Thank you very much to the organizers, the Sanar Council, for putting together this webinar on resin bolting. So today I'll be just touching on the fundamentals in the start and introducing the topics that needs to be discussed in the seminar. And that will then lead us into the details of the other presentations as well. Today I'll be just introducing the whole seminar and putting some fundamentals in place. For that, we have the application environment. So where do we install tendons? How do we apply that? Then we will be looking at some of the bolting systems and the components thereof. That includes the rock, the tendon, and then the resin itself. After that, I'll just quickly discuss the performance measurements. How do we do testing and what do we test for actually the moment we do that test? And then I'll conclude by putting down some requirements on the support systems itself. To start off with, the application environment, the question arises, why do we then need to do the bolting? Based on our risk assessments and the baselines we've put in place, it might be necessary to mitigate some of the risk, and the control measures to put in place to reduce that risk levels might be some bolting systems. We can also reduce the falls of ground, and we can also be instructed by the regulator to do that and apply a bolting system in our environment. Looking at the methodology in doing tendon support, various ways of methodologies of keeping the environment safe. Firstly, we can design a system to cater for collapsing wedges and make sure that stays in place, key blocks and sliding blocks. Also create a suspension system where you have weaker material suspended in the competent rock on top. We also can need to support on top of the tensile zone. We can create a reinforced beam, or we can also reinforce a total rock mass if we have a very bad quality rock involved. Looking at the bolting system, firstly we need to design with the application in mind. So why do we need to do the bolting? What are we going to support and how are we going to do the supporting on that? The three components within the system will then of course include the rock itself, the tendon which needs to be installed, and the resin which will apply the glue between the two outside components. Two planes of interaction are talked about. They are the rock resin interaction as well as the resin tendon interaction. So how do they behave, these interactions, and what is the bond strength between these as well? The next component in the bolting system is the rock. So based on the classification systems, these classification systems supply some guidelines on what type of tendon needs to be installed or other types of support, and also recommend how these systems need to be installed. So the quality and the strength of the rock therefore indicate systems and the guidelines now to install that. Water, as we all know, is one of the properties that we don't like to have in an environment. Firstly, reducing the quality of the rock itself as well as the integrity of the whole system. Now looking at the tendon, of importance here is of the material of which the tendon is made out of, looking at the length of the tendon and also the diameter of the tendon. So this makes up the whole tendon, the piece of steel that needs to be inserted into the hole, and then also the surface and the contact area of the tendon towards the resin area, and how does those two interact on the surface, and what's the restrictions and the application of those two environments. And now the interaction or the link between the tendon which is installed into the rock mass. Talking about the resin. The resin consists of various components, and that needs to be installed the right way around also into the hole. You have the components where you have the catalyst starting the reactions, and then the actual chemical reaction that supplies the glue, the contact between the two surfaces. The hole size versus the tendon size. As we talk about the annulus, it's important to make sure that that annulus is the correct dimension. Over over design or under design of those two could result in a different characteristics due to the mixing or the non-mixing of some of the resin components. And the curing time is also of importance. So as you put this bolt into the hole, as you spin it, you try to mix the two components, make sure that you have the sufficient mixture of the chemicals. The curing is also important, and to see how long you need to keep it there and make sure that the actual reaction do what it's required to do, resulting in a bond strength. Overall, where do you want the bonds to be? If you have a minimum length, do you want the length at the back of the hole? Do you need it in front of the hole, or spread throughout? And that's also important in doing the installation and a quality installation. As we do the installations, we need to make sure that and convince ourselves that the installation is actually of the good standard, and we have test procedures and protocols in place to make sure that these standards are kept. So when we are doing the test, the two types of tests that we can apply is doing a full column test, and in that test we test the overall installation quality of the system, and does it perform in the way we designed it to be. And when we then do a short encapsulation test, that's where we test the actual bond or the resin strength itself. Designing for the support requirements, firstly we need to design for the methodology. So if we are only supporting wedges that can slide out, it's a completely different design requirement than suspending a beam or building a stable beam. So that will also drive the length, for instance, or the quality of the bond length required if you use a certain type of resin. So those all play a role as you do your design. The loading conditions also, either being a static or dynamic loading condition, that will influence your ultimate design of the units that's required to ensure a stable environment. So there's now quite a mouthful, short session on what is actually looking at once we're doing resin installations and designs. To take this further on in the seminar, we're going to quickly talk about, and with other people, other presentations, look at the resin grout bolting system itself. There will be a presentation on the bar requirements, so what's required there. Again, have some details on the quality and how do you control and ensure the quality. Talk about the SANS document. Then the installation, how do we need to spin and hold, and why do we need to do that? There'll be a presentation on the annulus, and also then looking at the temperature and how does the temperature affect the quality of the installation and the shelf lives of the resin itself. So, and then just to conclude everything, highlighting the fundamentals of the resin bolting. We talked about the application environment, so that needs to be something that we need to consider. Why and where do you do the support? Looking at the three components, how does the quality of the rock influence the tendon that we need to install, and how do we bind those two elements? There needs to be some sort of performance measurement. How do we test for the bond strengths as well as the installation? And with all that said, we still need to have a certain requirement met with regards to support system to ensure a safe and stable environment. And with that, I would like to hand over to the host for continuance of the presentations. Thank you very much.